Hello everyone and welcome to my channel. We're going to do a very important, very interesting topic today. The topic name is dipole moment. Every year in JEE Mains and Advanced and sometimes in NEET also they've asked questions directly on dipole moment. They ask how to find dipole moment or comparing dipole moment of different species. So let's get started with the concept and understand what dipole moment is. So without any further delay, let's begin. So we'll first start with what dipole moment is. So let's begin. See, if you go for the definition of it, dipole moment actually is also something which comes in physics, right? Dipole moment mu is nothing but, see, it's the product of, it is the product of charge and distance between, it is the product of charge and distance between the positive and negative charges or the dipoles. What I'm trying to say is, suppose there's a compound HCl. So is this polar? Yes, of course, because hydrogen is less electronegative than chlorine. So chlorine will end up gaining electron from hydrogen. So as a result, what will happen? There will be a delta, a small positive charge on hydrogen, and there will be a small negative charge on chlorine. So these charges are the reason why this has a dipole moment. And this is the distance between the nuclei. So this is the distance. So the distance between the separation and the product of charges. That's what dipole moment is. So this mu is nothing but charge into the distance. It's a vector quantity because the distance has a direction, because in this case the direction is towards chlorine. So this is the formula for finding dipole moment. Now dipole moment is typically measured in a unit called as dBA, which is a very common unit we see, which is nothing but 3.33 into 10 to the power minus 30 coulomb meter. See, what's the unit of dipole moment? Unit of dipole moment will be, unit of dipole moment mu will be coulomb meter, right? But the common unit we use in chemistry is dBA, which is represented by D. So how to convert that? Just multiply charge into distance and then convert into dBA by dividing it by 3.30 into 10 to the minus 30 coulomb meter. That's it. But moreover, the questions asked in chemistry is on the basis of molecular structure and finding whether it's symmetrical or not, or whether it has dipole moment or not. Let's continue and see the other part of it. Now, see, let me give an example. Look at this molecule and look at this molecule. Hydrogen and hydrogen is bonded to each other. Can they ever have charges? No, because both the atoms are similar. So as they're similar, there will not be any charge. 0, 0. So mu is 0 because there's no charge. There's a distance, of course, but there's no charge. So mu 0. The molecule is non-polar. Therefore, dipole moment is 0. But in this case, see, there's a distance and there are charges, delta positive, delta negative, due to which it has some dipole moment, q into d, and it is polar. And it is polar. See? So non-polar, polar. That is how we can find the dipole moment of each of the cases. Right? So polar and non-polar is determined in this manner. Moving on. See, moving on to the next part. How do we find it? Like for this question, it was easy, right? Because it was the same molecule and all. But how do we find it in numericals or in compounds? So before we go any further, let me tell you one small theory. If you see that mu is 0, then the compound is definitely non-polar. Excellent. And the molecule has mu not 0, then it will be polar. That's it. Now, let me tell you a few theory which can help you to find questions, find a compound is polar or not. So let's go to the next page now. So these are the tips, I would say tips for finding dipole moment. So I'm going to give you some tips to find dipole moment. Let's do it. See, I'm going to list down some very important statements. Statement number 1, if the molecule given has no lone pair, 0 lone pair, the molecule given has no lone pair, Then what will happen? Then if the molecule, if the molecule has a symmetrical structure, okay, symmetrical meaning we can cut it into two halves, two equal halves. A molecule has symmetry, then it will be non-polar. Simple. The mu is 0 at that time. Meaning, suppose if you have a compound where, suppose you have this type compound, AB2. Is there any lone pair? No. So see, suppose if B is more electronegative, then electron will go out, the dipoles will cancel each other, mu 0. And also it is symmetrical, see. I'll talk about this dipole thing in some time. Suppose if it is AB3 type geometry, then also since it is symmetrical this way, see, if you take a knife and cut it from here, equal halves, mu 0. Suppose I have a case like this, tetrahedral. Even this is symmetrical because if I rotate it, keep rotating it like this, it's like a pyramid. If you rotate a pyramid, if you bring this side is and that side back, it doesn't matter. Same thing, right? If I keep a pyramid and if I keep rotating it, it will appear symmetrical again. So mu 0. If I have, suppose if I have trigonal bipyramidal geometry, even then it will be, yes, exactly, it will be symmetrical. So mu 0. Even if I have this last step geometry, even then it will be, see, symmetrical because I can literally cut it from here. See, symmetrical. So even this is symmetrical. So if you have any of these kind, it will be symmetrical. Moving on to the next tip, tip number 2. So please take a screenshot of tip number 1. Okay, let's go to the tip number 2. If a molecule has one lone pair, okay, if a molecule has one lone pair, then it will be polar always. Okay, it will be polar always. If a molecule has one lone pair, it will be polar always, no matter what. Like for example, ammonia. Is this polar? Definitely. Like NH3, NF3. Is this polar? Most definitely. Yes. Moving on, next point. If a molecule has two lone pairs, suppose. If a molecule has two lone pair, then it may be polar. We don't know. It may or may not be polar. We cannot be very sure about that. It may or may not be polar. So these are the hints using which we can find which of the molecules polar or not. Let me give an example. Suppose this is a molecule like oxygen, water. See, water molecule. And on the other hand, we have this molecule, like CF4. See, both of them have what? Exactly, both of them have two lone pairs, right? But this guy has a vector diagram like this. See, so it is definitely a non-polar molecule. But here, see the vector diagram, see, cancels each other. I'll talk about drawing dipole, don't worry. So they'll all cancel with each other. So mu will come out to be 0. See, so having two lone pair does not guarantee anything. If you have two lone pair, it may be polar, it may not be polar. So these are few tips I've given which can help you to find the stuff about whether a molecule is polar or not. Next, let me explain how to draw a vector diagram. Drawing vector diagram. There are a few rules that you may have to keep in mind while drawing vector diagram. Rule number 1. Rule number 1 says that lone pair has a greater dipole. Okay, it has a greater dipole. Long one, longer dipole. I would say longer dipole. Okay, than bond pairs because they have more electron density. As a result, the charge is more, distance is less, so mu is quite high. Second point, and goes away from central atom. That's also a thing you must know. See, it has, first of all, it's long and it goes away from the central atom. it will always go away from the central atom. That's the rule. Okay. Point number 2, the head of the arrow goes to more electronegative atom. Okay. And the tail, this part, goes to less electronegative atom. Okay. So the head, more electronegative, tail, less electronegative. That's how we can find it. Third one, you have to draw the vector diagram and you can shift it. Just since the vector concept, you can shift it. So let me give an example. These two are enough, I think. Let me give an example on how we can draw vector diagrams. So for example, BCl3, draw the vector diagram. So boron, chlorine, chlorine, chlorine. And one more example of ammonia, and then we'll wind up this video. Okay, so let's do it. N, lone pair, hydrogen, hydrogen, hydrogen. So tell me, which is more electronegative, chlorine or boron? Exactly, boron is less electronegative. So there will be a dipole where the head will go to chlorine and the tail will be at boron. And how to understand that is positive? See, it looks like positive. See, it looks like positive. That's why. Next, here it will go towards boron. Here also it will go towards this. So see, they are up, up and down. So total it will become 0 because they are cancelling each other. Now next one, ammonia. Since this is a lone pair, I will have a longer dipole. See, and away from new central atom. While in this case, hydrogen, nitrogen, nitrogen is more electronegative. There will be tiny dipoles towards nitrogen like this. So mu is not 0 because they are not cancelling each other. This is how dipole is drawn using these simple rules that I've given. So for now, we'll wind up this video. In next lecture, I'll give you some higher order questions on dipole moment, and we'll be doing some other concepts of it. So I hope you understood. If you like the video, please subscribe to my channel and share it to your friends. With this, let's wind up this video. Thank you so much.